Now, last week, our two topics, if you remember, were routing and design patterns, and they're the same two topics this week. But there was just one part of the design pattern stuff that we were looking at last week that I didn't finish off on, and I'd like to because it turns up in the Movies app application. So where I left off was when we were talking about this pattern called a render props pattern. And the basic idea is that a parent component can instruct a child component as to what it should render. And the way it does that is through a prop. We know that props are a way of passing stuff from a parent down to a child. Initially, we said we used props to pass data from parent to child. Then we realized that we could also pass a function from parent down to a child. The purpose of the function back then was to allow the child to essentially instruct the parent to change its state. If you remember this data down, action up pattern, if you can remember it. The third use case for props is in this render props pattern. Again, it's a function that's used, that's passed by the parent down to the child. The idea is that the child would invoke that function, but the function actually returns JSX. And the JSX that is returned will be used by the child as part of its overall output, or what it displays on the screen. That's the basic idea in English. And we had, as a demonstration, this little mini application, which allows us to display contacts or friends two different ways. And this was the design, which is the same design as we had a couple of weeks back when we were talking about this filtered friends application. And if you can remember what I said towards the end of last week's lecture, was that originally this relationship here was, I described it as being static, meaning that the only way that friend components were rendered was dictated by what import statement this component had. This component would statically import the code that renders a friend. So, you know, there was no way of changing the way friends were rendered other than changing the import statement, of course, but that's just changing your code. The way the render props is going to work is this component up here is going to, via a prop, tell this one how it should render individual friend components. And so this component at the top here kind of computes which type of rendering it should pass down to this guy. So code then, well, if I just start the app, and just for demonstration purposes, I just have two kind of buttons here, right? And depending on which button you click, the way my friends are rendered changes. Yeah. And so the main component is this app.js. It's one of the main components. And in terms of this filter, in terms of this render props idea, then let's see, it's this component here is receiving a render prop. And, you know, so here is the actual key line. So the prop is called render, doesn't have to be, but that's convention. What the prop is assigned is a function. It has to be a function. But if you look, what the function does is it returns a component. Okay. And in a moment, we will look at this component itself, the one that receives the render prop. Maybe we could do it now. And this is the line here where it's calling that function. Now, in this case, there's a slight layer of complication in that it's calling it within, it's mapping over my list of friends, and for each friend in my array of friend objects, it's invoking this render prop once for each friend. So the net effect, if you can remember from a few weeks back, is that this variable here now is going to be an array of friend components, and then we just display that array here. But what type of friends components is controlled by what the parent passes in as the render prop, and the parent is app.js. Of old, you see here, this line here, I've commented it out, but previously it was the file that I'm looking at now, the filtered friends list. It was that component that statically imported the file that contained the code for working out how to render a friend. It was statically done, but that I've commented out that line now because that doesn't apply anymore. Just left it there for demonstration purposes. So back to the parent, the one that actually decides how friends should be rendered. Well, to explain the kind of detail behind it. So friend here is, there isn't a component called friend, because if we scroll up, we can see, where do I have it? You see this line here. It computes what this friend variable should be assigned. Now, okay, for now, there's some sort of conditional test that it evaluates. And if that condition test is true, then I'm assigning friend image to friend. Otherwise, I'm assigning friend contact to friend. And friend image and friend contact are these two imports up here. So friend contact is essentially this rendering of a friend, whereas friend image is this rendering of a friend. But this app component that we're looking at, it actually computes which type of friend component should be passed down to the filtered friends list. Now, the condition test that it's doing here is just being determined by the button that I'm clicking. Sorry now for flicking around, but see here, when I either tick this button or I click this button, these two buttons have event handlers associated with them. And if we look at the event handlers, or maybe it's just one event handler. Let's see, where did I get it? It's this guy here, I think. Yeah, this is the event handler that runs when I click my buttons. Let's make sure that. You can see here. Oh no, it's not actually, it's set. No, it's not actually, sorry. So my buttons actually trigger or invoke a state change. So I've got a state variable on top there called format. There I have it. There you can see it there. And I initialize it to image, the string image. And depending on which button I click, the button click will either cause that state variable to change to contact or change back to image. It will flick between the two of them. So let's see now. So here's one button and it's telling it to change the state variable to contact. The other button is telling it to change it to image. And so every time I click the button, that triggers a state change. The state change means this app component re-renders, and every time it re-evaluates this statement here. And this statement, as I said, that's the one that determines what the friend variable should be assigned. It's either going to be assigned this component or this component. And it's that friend, that's what we pass down as part of our render prop here. So when the filtered friends list then receives this render prop function, it calls the function, and that's what determines how a friend should be rendered. The other slight kind of layer of complication is this function that I'm passing down is a parameterized function. It expects to receive a parameter, and it uses that parameter. You can see it kind of uses it over here. Right. So where does that parameter come from, you might ask? Well, the answer is when we map over the array, now this is kind of diving in maybe, but when we map over the array, which we do here, we're mapping over our array of friend objects, and we call the function, passing it in one friend object. So it's whatever object is currently being processed. That is the parameter that's being passed into my render prop function. So that's it's quite tricky, even though it's a simple, relatively straightforward example. But just to follow that code, you would need to go back, and I would suggest and make sure you understand the flow of control that's going on there. So we've looked at only two patterns, really, the container pattern, the render props pattern. There is a third one called the higher order components pattern, which I won't look at because it's not as popular today as it was maybe a couple of years ago, mainly as a result of this, of the introduction of hooks to the whole programming model. There is one other pattern that I need to look at, all right, which I may look at, which I will look at this week, probably not today though. Now, there is a general point to be made about this whole area of patterns, and it is that once you've looked at studied a pattern and seen one example of it being used, then arguably it's easy enough to understand the pattern itself. The difficult part is identifying an opportunity in your code to use a pattern. So being able to see, look at a piece of code and realize I could actually refactor that code and use a particular pattern instead to restructure the code and make it more maintainable, understandable, reusable, all those good things. That's actually the skill, more so than being able to understand the pattern itself. Obviously, you need time to understand the pattern as well. But once you've got the understanding of a collection of patterns, and we're only looking at two, and we'll be looking at one other, then that's not the challenge really. The challenge is knowing when to use them and seeing an opportunity to use them. I don't expect you to have that skill necessarily, but just making you aware of that. Right. That's render prop, one example of it, and we will use it in the movies app. So this week's technically is behind this card here. Same story, same structure. I've broken up the slides into 3 sets of slides actually, so they're all quite short. So we'll go back to, we'll start on this card, and as you can see from the title, we're going back to the area of routing or navigation, because in the archive that I gave you last week, there were, I think, 7 different samples, but we've only looked at 4 or 5 of them. So we need to look at the rest of them today. And just going to grab my slides. And as I'm at it now, I'm going to bring in the archive that we had last week. Right. So what I'm showing you here is the typical layout of web apps that we see, and it's fairly consistent across all the different kind of apps that you might come across, there or thereabouts anyway. By that I mean, by consistent, I mean you're nearly always going to get some sort of navigation headers at the top of your web app stroke website. It's there may be more kind of navigation links or a static part over here. There may be a static part at the bottom as well. Typically, as I say, all of these static parts would tend to contain some type of navigation links, but the critical thing is that they are static. By that I mean, as you navigate from page to page within your app, these parts, this part of the page doesn't change. What does change tends to be this area here. This tends to be dynamic. So the question is, how do we actually achieve these static parts across all our views or all our pages within a React app? And it turns out to be fairly straightforward, as it turns out. So for illustration purposes, again, we're sticking with this email client Maria that we're using throughout our samples. So in my inbox page, I'd like to have this header at the top of the page with some navigation links and maybe some other logos as well. Similarly, I'd like to have a footer part to the page, but I want those 2 elements to be repeated across all my pages. That's the objective. And it turns out that where we put those static parts is we can actually embed it in our routing configuration. So that header entry there and the footer entry, the 2 that I've highlighted, clearly this is a component, a custom component that I write, and you can have anything you want in it. It can be a parameterized component. In this case, it isn't, but it's going to generate my header, and it's going to be visible across all my different routes. And this one is going to take care of the footer part. So it's as simple as that, really. You can put up whatever you want to in here, but you can just, the trick is that the static parts that you want to have repeated across all pages, you actually include those within your overall routing configuration. And that's about it, really. That's sample 6. I mean, I'm not going to step through the code because you can look through that yourselves. But just to get it up and running. And if I switch over to sample 6, we're told. Okay. And irrespective of where I go, you know, it's going to always reappear. Yeah, it's as easy as that. I won't go through the code, but if you just look at the files within the folder, you know, clearly this one here contains the JSX for the footer part. This one contains the JSX for the header part, and the rest is fairly obvious. Now, I think I'm not using Material UI in this sample. I'm not using Material UI to generate this styling, but I do use, I do use Material UI for the website header that you will be bringing in to this week's lab in the Movies app. That's just by the way. So in a sense, there isn't really much point, even though I said I wasn't going to look at it, I'm now going to open it. It's all, well, I think I'm actually using the Bootstrap CSS library here, and we're not really interested in Bootstrap. So perhaps you can wait until you work your way through this week's lab, because one of the sections in this week's lab is to change the site header for the Movies app. Right, that's that. Next, programmatic navigation. So far, the only way we can affect navigation in our app or in a React app is through hyperlinks using the link component. But sometimes you may want to be able to trigger navigation. And by navigation, I mean trigger the change of the change to the browser's URL address bar. You want to trigger that from within your JavaScript code. You know, there might be some sort of condition test, and if something is true, then I want it to navigate to one URL. If it's false, I want to navigate to another URL. So how do we programmatically implement navigation in React? And there's 2 ways of doing it. And in most cases, you're free to choose which style you want to yourselves. In some minor cases, you have to take one over the other. But the 2 approaches to implementing this programmatic navigation, I'm classifying them as a declarative approach, or alternatively an imperative approach. With the declarative approach, we're told there that you have to introduce a state variable specifically to enable you to implement the programmatic navigation. And also you will use a component provided by the React Router library called the navigate component. We'll see an example of that in a second. If you want to take the imperative approach towards implementing your own programmatic navigation, there's a hook available to us that we use, and the hook is provided by the React Router again. So our little case study is going to be the following. The kind of typical use case for programmatic navigation is, you know, if you're on this web app and you're allowed to register or create an account for yourself, and you click the register button, you fill out a form, and you click submit, and if everything is okay, then you're redirected back maybe to the home page. So supposing we wanted to implement that. So, and I've done the registration using the 2 different styles. So that's why I've got 2 registration buttons here. But the way the flow of control in this little mini app is going to be, if I click on either one of the register buttons on the left, then it's going to bring me to my registration web form. And I don't really care about filling out fields now on this, so we'll skip that. Then there's going to be a register button. And when we click on the register button, an event handler is going to run, of course, an on-click event handler. Typically, that event handler would validate whatever details you entered on the registration form. And if it was happy with everything, then let's say it will redirect you back to the home page. Now, it's this second arrow is where we have what I'm calling programmatic navigation, because it's the event handler associated with the register button. It's that event handler that is going to cause the redirection back to the home page. And this is all done in sample 7. Yikes. Every now and again, I don't know if this happens with you, but every now and again, VS Code just crashes and it asks you to reload, but seems to reload back to the state that you were in before it crashed. So there's no harm done. So I'm up to 7. Save it. Let's see it working, even though it's very obvious. I've hopefully explained it so that click on any one of these and then click on that, and I'm redirected back to the home page. So if we look briefly at the code. So I've got a couple of routes, and just for illustration purposes, clearly this route here is the one that's triggered when I click the registration declarative button on my home page, whereas this one here is the associated with the registration imperative approach. As I said, I've implemented both of them. We've got our hyperlinks here. So this is the link from my, which one is this? This is the registration declarative, but hyperlink. In other words, this one here. So if we follow that, user clicks on that hyperlink. That changes the browser's URL address to /register D. Register D says load, register D says load this component, mount this component. And so this is the component now that's going to have the programmatic navigation, and it's going to implement it in a declarative way. So let's look at that. I did mention in the slides that if you're going to implement programmatic navigation in a declarative way, you're going to need a special state variable to help you. That's what this state variable is going to do for me. And I've just given it a name to reflect what it does or how it's going to help me. It's going to help me to redirect the user back to the home page. So I've initialized it to false. And let's skip over this for a second. I've got some sort of condition test here, which checks to see if that variable is true or false. So I've initialized it to false, so it means this is out of the equation. And so this is what is displayed on the screen. And that's true because if I click the register declarative, then that's what appears on the screen. And that's being generated by what I've just highlighted. My register button, though, is the one that I'm interested in. This is where programmatic navigation is going to begin now. When I click this, the register button, that triggers my event handler. Ordinarily, you know, there would be some code in here which validates the various details entered on the registration button. But then I change my state variable to true, which means my component re-renders. So it executes all over again. And now on this occasion, this statement is going to execute. And what I'm returning here, I'm returning a navigate component. It's the component that's provided by the React router. But really the way you kind of interpret what this line does is, what the navigate component does is it changes the browser's URL address to something. In my case, I'm changing it just to /. And as always, whenever the browser's URL address changes, then the app reconsults its routing configuration. And based on the routing configuration inside an index.js, we know what happens, as in, sorry, wrong index.js. It consults its routing configuration, and this is the route that's going to match. So it's going to take us back to the home page, and that's exactly what we wanted. So from a programmatic navigation point of view, the key things are the state variable and the use of, by returning this component, effectively, you are causing a change to the browser's URL address. But we're doing it in kind of a declarative way. For the imperative approach, it's the exact same flow, but if we just look at the alternative implementation, which is here, there's no state variable in this case, but we are using a hook. You use navigate hook, and that doesn't really take any arguments. What it returns is a function. And anytime you call that function, which I'm doing here, then again, the effect of calling that function, you pass it a string as an argument, and the string becomes the new URL address that you want to write to the browser's address bar. So it's an imperative approach versus the declarative approach. There's very little difference between the two of them, to be quite honest, but there you go. So again, this is the same. This is the event handler associated with clicking the register button in my app. And that's programmatic navigation. And we use that in the Movies app. That's the last of the routing samples. And so what we've learned about this React router library is it does, in general anyway, have a very declarative approach, in particular the routing configuration, the way you describe the routing configuration. We use components, and we nest components, we compose components with components. So, excuse me, it does follow the whole React programming model. And it also kind of adheres to this flow of event occurs. The event typically is now change in the browser's URL address bar. That triggers a state change, admittedly within React router itself. And the state change then triggers a re-rendering, which really is how our app changes from one page to the next. The React router library itself provides us with lots of components, most of which we've seen. There are others though. And it also provides hooks. And we've seen all of these three hooks. We've seen the use params hook, the use navigate hook, which we've just looked at right now, and the use location hook, which we've looked at as well. So go back and look at the samples in your own time, just to make sure you're clear on how to use React router, but we use it a lot in the Movies app anyway. That's that. I do take any questions if anybody had a question, but doesn't tend to happen, but that's okay. There's always the first time if anybody has a question. No, okay. Back to design patterns. So we're juggling these two topics, admittedly, over the 2 weeks period. So I did say there's one other pattern that I want to look at, and it has a specific application in a React app, and we actually use it in the Movies app, which is really, that kind of motivates everything that I do, which you really, do we need to use it for the Movies app? If we do, then we cover it. I think this is the set of slides. Yeah. Are we on time? We're okay. So the pattern is called the provider pattern. And when do we need to use it? So what's nice about this pattern now is that it has very specific use cases where it becomes useful, and it's quite easy to actually realize or identify an opportunity for it. Remember, I was saying there a few moments ago that the difficult part of patterns is to spot an opportunity to use the pattern. That's certainly the case in the case of the render props pattern and the higher order components, which we didn't look at. But in the case of the provider pattern, it's much more straightforward. And so the two, and they're interrelated really. The two cases where you should think about using this provider pattern is number one, where you've got some data, typically API data that's been returned by a web API, and there are a number of components in your application that need to use that data. So I'm calling it shared. There's some shared data or state within your application, and multiple components need to access it and possibly change it. So when you've got that kind of case, you know, one option is to pass it via props to all of the components that need it, but that can be a bit heavyweight, really. The alternative is to use this provider pattern approach. So you kind of centralize it, if you like. The other use case for it is to avoid something called prop drilling. Now, what's prop drilling? Now, this is an image that I found on the web, and I don't really like the emojis in the image, but I wasn't going to spend time trying to get rid of the emojis, but it does make the point anyway. So let's suppose this is a component hierarchy for an app, and you've got this component at the very top of the hierarchy, and it's a stateful one. And let's say the state is some API data, or maybe something that it has computed. It doesn't really matter. It's data anyway. But there are other components that need to know about that data, probably because they render it, or maybe even they triggered a change to it. So let's suppose this component needs to know about it, and this one does, and these two do. So if we didn't have the provider pattern, the only way we're going to make the data available to them is to pass the data via props down to the components that need them. And the intermediate components, like this one here and this one here, it doesn't do anything with the data. All it does is it receives it from its parent and it passes it on to its child. So all of these kind of intermediate components are simply transporters of that data. They don't actually use it themselves at all. This is what we call prop drilling, when data has to be passed down through the hierarchy to a lower component, but there's lots of intermediaries that have to take part in the transportation. And arguably, that's a bad design characteristic in your React app. We want to avoid that somehow. And the way we avoid it is to use this pattern. What am I saying here? So yeah, so prop drilling is, well, I've just explained it to you. Right. So before I show you what the objective of the pattern is, or how to implement the pattern, if you're going to implement it, and by the way, the provider pattern is not specific to React. It's not specific to web apps. It's a general pattern, unlike the render props, which is very specific to React, but in general, patterns are applicable to many different areas. But if we were to take this provider pattern and we want to implement it specifically in a React context, then there's a couple of moving parts or a couple of elements that we need to code up. One is we need to declare a component for managing the data itself. Okay, managing the shared data. That's always going to be the case, I suppose, but we're going to have one component, and that's going to be its sole responsibility, just for managing this data that needs to be shared across other, the various components. We refer to that component as the provider component. Number two, we need to create something called a construct called a context. And the context, I'm saying here, the context, it's actually going to be kind of physically where we store the data, even though the provider is going to manage it. The context is where we store it. And we associate this context construct with the provider. We kind of hook the two up. Number three, we place the data in the inside the context, as I've just said. Number four, we compose the provider with the rest of the app. So we have this idea of composition, which I talked about before. And finally, step five then is we use a hook, a special hook provided by the React framework itself. And the hook is used by the components that need to access that data. So they would have been the components at the bottom of the hierarchy that I showed you on the previous slide. The provider was the component at the top of the hierarchy. Now, everything in from 1 to 5 here, we've kind of talked about before. We've talked about components, obviously. The only thing we haven't talked about is this thing called a context. So that's a very React specific kind of construct, and it is central to this whole provider pattern. And really, that's the only purpose of this context construct. It is to allow you to implement the provider pattern. And so what I'm saying here is that it enables a component, this context construct enables a component to share data with other components in the hierarchy. Okay, let's move on. This is my attempt at visualizing the context idea. So the context is the orange box on the left. That's where we put the shared data. And as I kind of said on the previous slide, this is going to be my provider, because it's the one that's managing the data, and it's also kind of managing what goes into the context. Now, because I've put the data into a context, the other components that need to use it can actually access it directly, or we can imagine it can do it anyway. And this access is going to be achieved through the use of a special hook provided by the React framework. So there's no longer any kind of passing props down along the hierarchy. That's gone now from this picture, as opposed to the previous one. The components that need to access the data, we refer to those as consumers in this pattern. So we've got a provider component, a consumer component, and we've got a context construct. They're the three key elements. Here's some excerpts, code excerpts. So this is my provider component. So it's an ordinary component. Let's ignore this line for 1 second. This is just an ordinary component. So it has some stateful part to it. It may have a use effect hook to typically the data that's being shared is API data. So, there's probably a use effect hook that grabs that data. Now, other than that, it's just an ordinary component. Let's ignore what it returns for a second. This line here is really important. This line is where you declare your context construct. Okay, so it's just a simple method call on the React framework itself. So my context is, I've called it some context. How do I connect, the context with the provider? This is how we do it. And this is the only part of the pattern that's a little bit clunky, in my view anyway. But so the provider component, it returns, it kind of reshapes the context as a component by going some context dot provider. Some context is strictly the name of the context construct, but it turns out that a context can also double up as being a component as well. And the way we do it is by going .provider. So that's fine. Now, what's this values prop that we pass to the context.provider? The values prop is an object, and it's going to have a set of key value pairs. And the key value pairs that you put into this object, that is what dictates what goes inside the orange box on my previous slide. So really, what you put here is what controls what goes into the context construct, and consequently, what is available to the other components in your hierarchy. And finally, we've seen props.children before. I am now, the effect of this line here is to compose other components with this guy. Okay, so a lot going on there, but that's the provider component part of the provider and the context, I suppose. But there, you can't have one without the other, really. I am saying down here, right, that you can put functions into the context as well, and we actually do that. Sometimes there may be functions that lots of components in your component hierarchy would like to be able to invoke. In other words, they're shared. So put them into a context construct, and that's the way of sharing them. In this slide, this is the kind of second part of the whole composition. Where you actually use the context provider is you actually mix it into your routing configuration. Okay, so here is context provider. That's the name. If I go back, that's the name I gave to my provider component. And, you know, as I said, I'm mixing it in with the routing configuration. Now the dot here, that's where I have all my routes. So I'm essentially composing the context provider with all of the other components or pages, if you like, in my app. And therefore, all of the other pages potentially will be able to access the data or functions inside the context construct that is being provided by my provider component. And the final piece of the jigsaw then is the consumer component. That's the one that actually wants to grab some of the data from the context or invoke the functions. So here are some excerpts from a typical consumer. There's a special hook, you might remember. I said there's a special hook that the React framework provides, which will allow a consumer to access a context. And that's hook is called use context. So here I'm using the hook. Now, what am I passing to it as an argument? What I'm passing to it is the context construct, I'm not passing it the provider component. I'm passing it the context construct. You can see me importing it here. Now, just to be clear, what I'm importing here, if I just go back, what I'm importing is this guy. Because you can see here, I'm actually exporting it. So I'm importing the context construct itself. And by, I know I'm jumping around now, but the real effect of this line here, so I'm using my hook, passing it the particular context construct. So what does it return? What it returns is essentially this values object here. And I said that this values object, this is what really is put into the context by the provider. So that now means that my consumer has access to this full object here and therefore has access to any parts of the orange box, if you like. Here's my consumer. So that's going to be referring to effectively the values object, i.e. the contents of the orange box. And then you can just, dereference any particular key within the orange box that you want to access a particular element within, or property, if you like, within the context construct. So it's never easy to understand these things when you're just flicking through slides and showing your code excerpts. You want to see it all working in a real app. And again, you will get that opportunity. I don't think it's in this week's lab. It's in next week's lab that you'll see me using this. Essentially, what we will be doing is the list of movies that we recover from the TMDB API. Turns out that there are a number of pages that need to access that list of movies, i.e. it's shared data. So we're going to create a context, which I think I call the movies context, which is going to have the list of movies. And we'll also store the favorites in that context construct as well. Right. Where does that leave me? Talked about that. There are occasions when you should not use the provider pattern, and I'm only including this slide just for completeness sake. It won't be a decision you have to make, but number one, you're told that don't use the provider pattern if you're only passing props down maybe 2 levels. That degree of prop drilling is acceptable. Now, admittedly, I think I break that rule in the Movies app. There may be only 2 or at most 3 levels that I avoid by using the provider pattern. But in general, for larger apps, then you shouldn't just introduce the provider pattern if you've got what I'm calling if you've only got shallow prop drilling, or if what you're trying to avoid is shallow prop drilling, because it turns out that the provider pattern can affect the performance of your application. And by performance, I mean how smooth the transition is from page to page. Second case is to save, sorry, no, save state that should be kept. Oh yeah, well, just because you've got a component that's stateful, don't just say, sure, I may as well put that state into a provider component. If really there's no other component that needs to know about that state, I guess that would be fairly obvious. So keeping state local to a component is always a much better option if you can do that without resorting to putting that state into a shared component. The other, I think what I was trying to actually deal with here is if the state that you're considering putting into a context construct, if that state changes very regularly, then do not use the provider pattern in that case. I won't go into the details, but that's the, because if you think of the Movies app now, well, we retrieve the movies from TMDB, that list isn't going to change, or it's not changeable by the user. So it's appropriate to use the provider pattern in that case. The fourth case is if the actual objects that you're putting into the context construct, if they're very large objects, then you should possibly reconsider not putting those large objects into a context construct as well. As I said, you won't really need to worry about these things, but I'm just including that slide for completeness. Custom hooks, I'm not going to cover that today. Right, I cover this few slides next day with you, and we need to go back to, I've got a use case, if I just briefly, the third set of slides here is a nice little use case that uses the provider pattern and uses some of the navigation, a lot of the navigation or routing features that we've looked at so far. So it kind of brings them all together in a nice little, fairly obvious use case, but still. So that's for Wednesday. Okay, if there aren't any questions, I'll just hang on for a second, but if there aren't, we'll leave it at that for today. No, okay, I'll talk to you on Wednesday. Bye for now.